Today we are going to study the atomic structure, the basics of the atom. That is the electronic configuration, the ionic bond, the covalent bond. So for that we have to know about the structure of the atoms and the electronic configuration. So before that, let me introduce myself. I am Momita Seth. I am maths and science teacher and I am teaching for the last 10 years. And I have done my BSc in chemistry major and BTech in food technology and biochemical engineering from one of the best university of India. So let's start with our topic, which is atomic structure. So atom is the basic matter of basic structure of every matter, and we will study about the atomic structure. So atom, as we know, is made up of three subatomic particles: electrons, protons and neutrons. Electrons are negatively charged, protons are positively charged, and your neutrons are electrically neutral. So let's see how they are arranged inside the atom. So I'll draw the structure here because it is not visible because of the light. So this is your, suppose this is a nucleus, and here are the energy orbitals around the nucleus. So this is a place, nucleus, where the nucleus, it is called as your nucleus, which contains the protons and the neutrons in it, which is centered inside the nucleus. Okay, and these are the energy orbitals. Okay, we call it as energy shells, we call it as orbits, we call it as orbitals. So the electrons are present in these orbitals. What is atomic number? Atomic number is denoted by Z in your periodic table, and it actually gives you the total number of protons. An atom as a whole is electrically neutral because the number of electrons and the number of protons are same. That is, the amount of positive charge cancels the amount of negative charge in it. So as a whole, the atom is always neutral. Next comes the mass number or the atomic mass. The mass number or the atomic mass is the total number of the protons and the total number of neutrons in it, and it is given by the symbol capital A. So this is your total number of protons or neutrons, which is giving you the atomic mass or mass number. Now the mass of the electrons is very negligible as compared to the mass of the protons and neutrons. So in the mass number, we neglect the mass of the electrons and we only consider the mass of the protons and neutrons. So if we know the atomic number of an atom and if you know the mass number of an atom, we can easily find out the number of neutrons. So your number of neutrons will be mass number minus your atomic number, that is A minus Z. So this is the introduction of the atomic structure. Now next we will study how the electrons are arranged in the electronic orbitals or the energy shells which are present around the nucleus. Now this is your atomic structure. The shell which is closest to the nucleus, we number it as 1, and the next shell we number it as 2, and the third shell we number it as 3, and so on. Okay, the first shell we call it in the alphabetical order. By alphabets we address them, capital K. Second shell we address them with capital L. Third shell capital M. Fourth shell capital N, and so on. So now the electrons are present in these shells. Now the first orbital which is closest to the nucleus is filled, then the second orbital, and then the third orbital. Now there is a maximum limit of each shell in which the electrons will be filled. What is the maximum limit of the electrons which can be filled in a shell is given by the formula 2n square, where n we are showing it for the number of the orbitals, that is the level, energy levels. Okay, so for first energy level, the maximum number of electrons that can be filled is 2 into 1 square, that is 2. Second one, will be your 2 into 2 square, that is coming out to be 8. Then this is 2 into 3 square, that is 18. This is 2 into 4 square, which is coming out to be your 32, and so on. But when we will start writing the electronic configuration, there will be again some more changes which we will learn about that. So for this we will have maximum electrons in it 2, we will have maximum electrons here 8, we will have maximum electrons here at 18. But no, there is some change and that is called as an octet rule, that when we will be writing the electronic configuration, the maximum number of electrons it can hold in its valence shell is given as 8. So we will learn why it is 8 and not 18. Let us write the electronic configuration of some of the elements, some of the atoms of the elements. I have taken hydrogen, lithium, boron, oxygen, fluorine, neon, sodium, argon and potassium. The atomic numbers I have written over here, and we will see how the electrons are arranged in that energy shells. Okay, so one electron, it will go to the first, that is, it will be one first shell. Then it is your lithium. So first shell will have 2, not more than that. So one more electron is left. It will go to the second shell. Next comes boron. So again first 2, then 3 is left. The second shell has maximum 8 capacity. So 3 electrons will together go into that second shell. Then comes oxygen, again 2, 6, because it will be again going to the second shell, all the 6 electrons, because the maximum limit is 8. Then for fluorine it will be 2, 9 minus 2, how much? 7 electrons will go to the second shell, because the maximum limit is 8. Now for neon it will be 2, how much? It will be 8. 2 plus 8 makes 10. So here the octet configuration is fulfilled, that is the valence shell has 8 electrons. So where the valence shell is completely filled, we call those atoms as inert gas or noble gas. Okay, this is one inert gas. Next comes sodium. So 10, 11. So 2, 8, this one is second shell is completely filled. Now the electron will go to the third shell. Then comes argon, and in between sodium there are so many elements like sodium, magnesium, beryllium. So then your silicon, all these will be there. So it will be 2, 8, 1, then 2, 3, 8. Now in this way it will be 2, 8. Argon will be again 8. So again the third shell is getting completely filled. So again here in argon we are getting inert gas. Argon is another inert gas. So after hydrogen another noble gas comes, which is helium. The electronic configuration is 2. So this is one inert gas here. Then lithium, boron, then it keeps on going. 8 will be there, 8 elements will be there in between. Then we will get this neon, then neon to sodium, and then magnesium, beryllium, and this will go till your chlorine, and after chlorine you will get argon. So after that we are getting potassium. So it is 2, 8, 8. Now no more electrons in the third shell. The 19th electron will go to the fourth shell. Even if it has got maximum capacity 18, the 19th electron will not go to the third shell, it will go to the fourth shell, because it has got completely filled orbital. It has got 8 electrons in its third shell. Now the 19th electron will go to the fourth shell. Okay. So for calcium, the atomic number is 20, and the electronic configuration will be 2, 8, 2. So this way the electronic configuration are written. Next we will learn how to find out the number of electrons, number of protons and the number of neutrons from their mass number and from their atomic number. So here hydrogen, its atomic number is 1. This shows, I have already told, that the atomic number is equal to the number of protons in the atoms. Remember that it is the number of protons in that atom. And so your hydrogen atomic number is 1, so your number of proton will be 1, and as because it is atom, so number of protons and number of electrons are equal, so your number of electrons will also be 1, and your mass number is 1, so your number of neutrons will be mass number minus atomic number, or mass number minus number of protons. So 1 minus 1 will give you 0, so there is no neutron in hydrogen. Okay. Then comes your lithium. So for lithium, atomic number is 3, so your number of protons is 3, and you can fill up this way, so your number of neutrons will be 7 minus 3, 4. Boron will be again, the number of protons will be 5, so it is electrons will be also be 5, so, and the number of neutrons will be 6. So it will keep on going like this. It will be protons is 8, and your number of neutrons will be 8. Now if I take the iron, oxide ion, so iron means if it has gone, the charged particles, it has become charged. Now how the atoms gain charge? So when they lose electron, they become positively charged, and when they gain electron, they become negatively charged. So why they are gaining, so that we will come afterwards. So when they are gaining electron, here oxygen has gained 2 electrons. So now what will happen? 8 electrons and 8 protons are balancing the charge, but these 2 electrons have increased. So these 2 negative charge cannot be balanced, so the resulting oxygen ion has now 2 resulting negative charge. So what will happen to the atomic number and mass number? Atomic number never changes, even if it is an ion. The atomic number will remain 8. The mass number will also remain the same, because the addition of electrons or the removal of electron does not add anything to the mass number. So your atomic number is 8, your number of protons should be 8, your number of neutrons should also be 8, but the number of electrons is no more 8. It was already 8 and 2 more electrons were added, so now the number of electrons will be 10. Remember this, when an atom becomes an ion, there is no change in their atomic number or mass number, but there is only change in their number of electrons. Okay. So now we have neon. Neon 10 will be the number of protons, number of electrons, and 20 minus 10, again the number of neutrons is 10. Let's take sodium. Sodium, the atomic number is 11. So the number of protons is 11, number of electrons will be 11, and your number of neutrons will be 12. Now if I consider sodium ion is positively charged ion. Okay. So as I told, if it is an ion, there will be no change in its atomic number or mass number. So your atomic number will remain 11, mass number will remain 11. That means that the number of your protons will remain 11, the number of neutrons will remain 12. What will be, what is the change here? Here it is losing 1 electron. So as because it is losing 1 electron, so the 10 electrons is neutralized by 10 protons. Now the charge of the 1 proton cannot be neutralized. So that is why the resulting sodium has 1 positive charge. So this shows that sodium ion has lost 1 electron. So here the electron will be 10. Okay, so have you understood how with the ions the atomic number and the mass number remains constant, so the number of protons and the number of neutrons will remain constant, only the number of electrons are going to change. So now you have to find out what will be all these numbers, that is the mass, electron number, the proton number and the neutron number for potassium and calcium, and let me know the answer.